In this presentation, we're going to discuss about function pointers. So we have seen pointers to data like integer pointer, character pointer, structure pointer, etc. So those type of pointers point to normal data. It can be anything. So in general, function pointers are a different type of pointers which cannot point to any kind of data. It can point to only code which CPU can execute. Fundamentally, the executable code is functions in C. So we call them function pointers. So function pointers, it's a very important topic. Many of the books and courses are not giving enough importance to this topic. But if you look at a production code, you will see always function pointer in use. Sometimes the syntax of the function pointer, if you're not familiar, can be a little bit complicated as well. Let's have a look at this program. So we have a function called func here, and what we are doing is we are printing func. In this case, func is nothing but an address which points to this particular piece of code. So we have this program up here. So this is a function. Let's see the output. So this is the output of this program. C6 1000. So what I'm going to do is I'm going to copy this address. I have copied that address and I'm going to see the disassembly of that. I'm copying it to the disassembly address window. So if you look at here, you can see the function is starting. So this is the starting instruction of this particular function. So the address we have printed is exactly same as this. Now if you look at the memory, you can see some data up in this address. So basically these are the bytes of these instructions. So to see that, what we can do is you can click on show code bytes in Visual Studio. So this is the binary value of this particular instruction. So 55 is the binary or the machine code of this particular instruction. Like that, this. So every instruction has a machine code or the binary representation. So that is what is here. So if you look at memory, that is what is here. So 55 8B EC. So it is there in the memory in the same order. So 33 C0 all here. So basically this is a code which this particular function address is pointing to. Now we will see how we can take this address into a variable, a pointer variable. So in the previous program, the type of func is this. So this is the return value of the function. This is the argument which is passed to the function, and this part will shows that this is a function pointer. So this parenthesis is mandatory. We cannot omit that parenthesis. So do this star. So the type of func in the previous program is this. It is not exactly this particular type. Like in the case of array, we have a constant involvement here, which we are not going to discuss here. So we are going to assume that this is of type int star char a. So func is an address to some code which can be executed. As I mentioned, it's not exactly correct to say that func is a function pointer, as there is no variable associated with it. It's a constant pointer actually. You cannot change it. You cannot assign anything to func because it's a constant. So we will see the variable declaration here, the function pointer variable. So this is the general syntax for function pointer. We have already seen this. So the return type, in this previous case it was the int, then an open parenthesis, then this star, then the name of the function pointer. The name should come here, and then the parenthesis is closing. This parenthesis we are closing it here, and then the arguments here. It can get a little bit complicated in certain scenarios, which we will see soon. But in production code, we will rarely get complicated function pointer syntaxes. All we have to do is watch out for this pattern. This is the return value or the return types. This is the arguments which is passed to the function, and most important is this part. So again we have the function here, nothing special here. So I have a function pointer declaration here, int star func ptr char a. So this is read as a function pointer which takes a character and returns an integer. That's how it is read. So this is also of type of that. It takes a character and return an integer, this particular function. In this case I can assign this func to this func ptr. Here is how I call the function. So when I do this, it is calling this particular function. So when you do this program in Visual Studio, make sure that, as usual, when you look at disassembly, your build is release and your optimization is disabled. In the debug build, this func contains an address which is different from this particular function. So it is a debug feature in Visual Studio. Don't worry about it. Just change the configuration to release and disable optimization in project properties here. So I'm going to execute this program. So I have the function address. We have seen this function address before. So I'm going to assign that function address to this function pointer. So currently that function pointer contains some junk value. So I pressed F10. Now it is containing 000 D1 000, which is same as 000 D1 000. This func. Now all I'm doing is executing that function. So I'm going to press F11 here. So it came here because I'm executing that function. So if we go to the disassembly, we will see the same address. So rest of the thing is fairly straightforward. So after the execution it comes back. It's just like another function call. So if you look at the disassembly here, here is a copy of the function. If I change the viewing option, to do not show symbol name, you can see pretty much hard-coded address here. Function pointer is just like any other pointer. It contains an address to some code. So it is a 32-bit value. So you can see that it is EBP minus 4. So only 4 bytes are allocated on the stack for that variable, EBP minus 4. So that is the first local variable. And we are copying a word, which is the address to the function. And if you look at, we are just calling dword ptr EBP minus 4, doing a call instruction, so that this address will get loaded into the EIP. So very simple concept if you understand correctly. It has a lot of implications. So we have seen this program. So we assigned the address of this func to funcptr. So this is the type of funcptr, and we are calling the function like this, and we saw that this function is getting called. So a little bit more understanding on the syntax. I would like you to concentrate on the colors here. So the colors in the yellow, which I'm highlighting now, is the type. So it is like int, and the identifier, the variable, is this. It's not very obvious from the syntax. So the yellow part is exactly similar to the yellow part here. So it's just like int a, this entire statement. In the previous example, what is funptr here? It is a pointer variable which can hold a function address, as we discussed. Not all the function addresses, but only functions which are returning an integer and taking a character as argument. So in this example, this funptr can point to only functions which are returning an integer and taking a character. So a couple of uses of function pointer. So in almost all the different uses of function pointer revolve around the fact of callback routines. Modern day computing is always event based. So basically something happens in the system and a piece of code is executed in response to that particular event. For example, an interrupt, a mouse move, a keyboard, anything from the hardware or from the user, any such events. The programmer will be asked to give a function pointer to some framework, and the framework will call that function pointer when that particular event happens. It's like you are going to a grocery shop, you search for something, that something is not there. Now what you're doing is, now you're telling the shopkeeper, call me back in this number when this particular thing arrives. So the shopkeeper is a framework, and you are the programmer which is giving the function pointer, which is the phone number. So this is an example of callback. So you have a normal function here. So from the main, what you're doing is you are doing a very long job. You don't know when that job is going to get completed. So in this particular function, it's a long function. It takes a function pointer and a character. So what it does is, it does the job, and once the job is completed, it'll call back this particular function which we have provided here. So in this small example, you may not understand the complete significance of this program. So when you do multi-threading, when you do framework-based programming, or when you write a device driver which handles an interrupt, so this function is equal to the callback function. For example, an interrupt handler. To reduce the syntax complication with function pointer, normally a typedef is used. So typedef int, then parentheses star, then the name of the type, then the rest of the declaration. So you can use syntaxes like this. It makes things more readable. So you can call like this. So from a program standpoint, it is not much different from the program we have seen before. So the output of the program is obviously job completed. Now let's see another program which has a little bit more complicated syntax. This is how the normal use of function pointer in production. In a live scenario, this is how the function pointers are used. So you have a structure here, you have a global structure. So that structure contains an integer and an array of function pointer, my func ptr table. So it's an array of 5 function pointers. So what is the type of this function pointer? The type of the function pointer is this. So it takes an void and returns an void. So here I have 5 functions with this signature. Function 0, 1, 2, 3 and 4. So let's see what I'm doing in the main. In the main I'm calling initialize my struct. Unfortunately L is missing. Not a big concern for us. What is happening in initialize my struct? We are initializing the global structure with the function pointers we had. We are assigning the first one to func0, second one to func1, etc. until the fourth one. So in the main we have an infinite while loop and we are scanning the event. We are taking an integer from the user and depends on that event we are calling the function. So this is how the function is being called. So this syntax you may have to take a little bit care. My struct 1 dot, then the function pointer table, then the index, then this operator, the function calling operator. So that is some syntax, new syntax probably. Have a clear look onto it. So depends on the value user is inputting, that particular function is getting called here. So event now is a value we are scanning from the user using scanf function. So this is a typical production usage of function pointers. So for example, you can assume that this particular table can be an interrupt descriptor table or IDT in the case of a hardware. So in the case of C++, this can be a virtual function pointer table. So if you understand this particular program, you may not have problem with any function pointer in any production code. So this syntax you may have to remember. So it's again a new syntax fairly, although it is kind of convenient other syntaxes we have studied so far. So now let's see the execution. So it's an infinite while loop. So I'm entering 1. So then the function 1 got executed, 3 got executed, I'm entering 4, 4 got executed. So if I enter 7, nothing will get executed. So again 2, like that. So these are some of the uses of function pointer. This is not a complete list, but this covers pretty much everything. As I mentioned, all these uses are revolving around the fact of callback, or letting you know something happened. Multi-threading. So when you create a thread, you give a function pointer from where the execution should begin. Dynamic link library, export a table of function pointers. Hooking, if some operating system or library is not providing enough functionality, you can hook that library and modify the behavior by changing the function pointer inside that library. That is called hooking. That is pretty much the same technology used in virtualization. So you change instructions executed by the CPU or the operating system to something different. So that is the principle behind virtualization. Plugin model programming. So for example, a Google toolbar inside Internet Explorer. So Google toolbar is giving a table of function pointers to Internet Explorer to call. That's how it is a plugin of Internet Explorer. Same with Adobe Flash Player. Those are plugins. C++ virtual functions. So any kind of event-driven programming. So user is entering some value text, moving mouse. You use function pointers to manage those kind of events. Basically arise from the fact that events are nothing but interrupts, which is to be handled by an interrupt service routine, which is a function pointer. Hopefully in future presentations we will explain some of these topics. So we are nearing to the end of the discussion regarding pointers. So these are some of the comments from K&R-C. I would recommend you to read that book, The C Programming Language, by Kernighan and Dennis Ritchie. Again from the same book. So most of this we have seen so far in different presentation. So it's a double pointer actually. I'm not explaining all of them. So I have rarely seen this complicated syntax in production code. Same with this, but others I have seen, and I would say it's not that complicated. So being said that, I'm concluding our discussion on pointers in C, and thank you very much.